Section 2.5, example problem 3, multiply rational numbers. Well, we already know that when we multiply two numbers whose signs are the same, whether they're both positive or both negative, our resulting product will be positive. The same thing applies when dividing. If the signs match and we're dividing two numbers, the result is positive. Now when the signs don't match, so we have one negative and one positive, regardless of whether we're multiplying or dividing, the result will be negative. So let's get to work on this problem. Negative 2 3/5, a mixed number, times negative 1 1/4, another mixed number. Now to multiply, recall we don't need common denominators. We'll do some simplification if possible, maybe cross-reducing, but we don't need to seek out a common denominator. That's something we need to do when we're adding or subtracting fractions. So here we're multiplying. Let me continue to the right. Negative times a negative will be a positive. So immediately we can ignore the negative signs and proceed as though they weren't even there because we've checked and we know our result will be positive. The next thing we need to do though is to convert these mixed numbers into improper fractions. And much like the last example problem, the process for that is denominator, in this case, or the case of the mixed number on the left, that's 5, times the whole number, for us that's 2, plus the numerator, 3. So again, that's going to be 5 times 2 plus 3. 5 times 2 is 10, plus 3 is 13, so our improper fraction will be 13 over our original denominator, 5. Now we'll be multiplying by negative, or we're ignoring the negative signs, 1 1/4. So we need to do something similar to convert 1 1/4 to an improper fraction. 4 times 1 plus 1 is 5. And our original denominator was 4. All right, now before we multiply, we should cross-reduce. Anytime we can cross-reduce, we should. That will save us some work. It'll keep our numbers a little smaller, probably less chance of making errors if we cross-reduce. So first, let's seek out in 13 and 4, the value across from the 13 at a diagonal, any common factors. Well, if I think about the factors of 13, I know 13 is prime, so its factors are 1 and 13. Also, negative 1 and negative 13. 4 is not prime. It has factors 1 and 4, 2 and 2, but then also the negatives of both of those. So maybe I'll be efficient here and write plus or minus 1 and plus or minus 4, and then plus or minus 2, plus or minus 2. See, that just represents both the positive and negative values of each of those numbers. All right, now I'm seeking out common factors. The only one is 1, and technically negative 1 as well. That doesn't do us any good. We can divide 13 and 4 by 1 repeatedly and not get any simpler of a fraction. So 13 and 4, we will not cross-reduce. 5 and 5, on the other hand, well, that just screams out to be cross-reduced. 5 and 5, since they match, they both have a common factor of 5, and we can divide. 5 and 5 divided by 5, they both become 1. So we cross-reduce. Sometimes it's called cross-canceling when they cancel out so nicely. And now we have numerator times numerator, 13 times 1, 13, over denominator times denominator, 1 times 4. Again, a reminder, we do not need to find a common denominator when we multiply fractions. 1 times 4 gives us 4. Now 13/4 is an improper fraction, and often, as you can see is the case in this problem, we're asked to write as a mixed number. So we'll have to convert back to mixed number form. So we consider how many times does 4 go into 13, or how many groups of 4 fit into 13 without going over, so without being too many. 4 times 3 is 12, so right away I recognize 3 groups of 4. go into 13, but one more would be too much. That'd be 4 times 4, and that's 16. Taking out 3 groups of 4 from 13, we have one remainder. So one value remaining, and that becomes 3 1/4. A quick double check. 4 times 3 is 12, plus 1 is 13 over the original denominator. So it works out. It's often good to check your work by performing the opposite, or working backwards a step. And once again, we find a guided practice problem following an example problem. And once again, I feel I've guided you through the example problem and would like you to complete the guided practice problem on your own as a check of your understanding. So multiply rational numbers. -3 1/4 times -2 2/3